Welcome to the lecture on linear expressions and equations. This video will cover a very introductory presentation of the two equations and expressions. And we'll talk about some examples and go ahead and solve some one-step equations. So the difference between an expression and an equation all comes down to the presence of an equal sign. So an expression is a number or variable or combination and operation symbols. So you can think of exponents or plus, minus, division, etc. An equation is made up of two expressions connected by an equal sign. So here are four examples. In the first one, we have an equal sign, so it is an equation. In the second one, no equal sign, just division. So this is an expression. The third example is an equation, and the last is an expression. Again, just looking for the presence of an equal sign will kind of lead you down the right path. All right, so let's solve a one-step linear equation using addition and subtraction. The whole process is going to be centered on treating both sides equally. So if we want to solve x plus 3 equals 5 for the variable x, we notice first that x is with a plus 3. And so we want to isolate x. And the way that we do that is we undo what's been done. So 3 has been added to x, so we need to take 3 away from x. But also keeping in mind that we need to treat both sides equally. So we're subtracting 3 from both sides. And if we do that on the left-hand side, the 3's will cancel, and we're left with x equals 2. Here's another example, x minus 12 equals 1. So we need to isolate x by adding 12. Since 12 has been taken away from x in the original equation, we need to undo that by adding 12. And we need to do it to both sides. This will cancel out the 12s with the x, and we're left with x equals 13. Negative 8.1 equals negative 41.5 plus x. So again, we need to isolate x by canceling out that negative 41.5 on the left side. The way that we can do that is we can put a positive 41.5 on the right side, and that should cancel out. And so on the left-hand side, we'll just combine negative 8.1 and 41.5. So in your calculator, you could type negative 8.1 plus 41.5, and you would get 33.4. So x equaling 33.4 is our final answer. Sometimes we'll have equations that are equal to 0, and that's okay. Equaling 0 doesn't mean that you need to get rid of the equal sign or just kind of have it drop off in some way. Maintain the 0 on the left and follow the same process as before. So we need to add 2/5 to isolate x, and we need to add it to both sides. So that's going to give us the cancellation we need on the right, so that x is isolated by itself. And on the left-hand side, we have 0 plus 2/5. So 2/5 equals x is our final answer. We can also solve one-step linear equations using multiplication and division. So our equations here would look like, as an example, 2x equals 4. So the 2 is being multiplied with the x. And the way that we undo multiplication is through division. So in order to isolate x, we'll need to divide each side by 2. On the left-hand side, the 2's will cancel. On the right-hand side, this simplifies to just 2 over 1, which is the same as 2. So x equals 2 is our final answer. And our next example here, negative 3x equals 5. When we are isolating through division and multiplication, we need to make sure to pay attention to our signs. So if I have a negative multiplied, then I need to undo this multiplication by dividing, and I need it to also be negative. What does that mean? I need to divide by negative 3. So in math, I like to say that 2 wrongs make a right. So in order to cancel out this negative 3, I need to divide by negative 3. And notice that it's a little bit different from the addition subtraction. With the addition subtraction method, you had to change signs. Well, in the multiplication division pairing, you need to maintain the same signs. Okay, so -3 cancels and we are left with x equals 5 over -3. Now, typically we don't write the negative sign in our denominator. So our options are writing it out front of the whole fraction, so negative in front of the fraction, then 5/3, or we could put the negative sign in the numerator, -5 over 3, and both of those are acceptable. In this example, we have -x equals 10.1. So there's no number in front of the x, just a negative sign. So what this actually means is there's really a -1, and it's just understood even though it's not written. So now that we know it's -1, we can cancel by dividing by -1. And on the right-hand side, if I divide a number by -1, all that does is change the sign. So I do have 10.1 over -1, and that is the same as -10.1. We may also have the case where a multiplication or a product is equal to 0. So in this example, 0 equals 24x. We're going to apply the exact same process. I've multiplied x by 24. So in order to isolate it, I need to divide by 24, and I need to do that on both sides. So on the right-hand side, the 24s will cancel. And on the left-hand side, I have 0 over a number. So you might remember that 0 over a number, 0 over a non-zero number in particular, is always just going to be equal to 0. So 0 over 24 is 0. 0 over 1 is 0. 0 over -1,000,005 is still 0. So I'm going to get 0 equals x. And you may recall from earlier days in your math history that you cannot divide by 0. So if you were to have something like 24 over 0, then you can say undefined or there's no answer, whatever. But 0 over 24 is totally valid, and the number or the value of that is 0. Another way to think about this is saying the equation 0 equals 24x is the same as, well, what number times 24 is going to give me 0? Or 24 times what is 0? So what do you have to multiply to get to 0? Well, you would have to multiply by 0. 24 times 0 would give you 0, and that's the only option you have. It's called the zero product rule. If you are interested, you can look that up. But for now, it's just dividing by 24, totally fine. The end.